is the FarmBeats Accelerator, the capstone project for this semester.
All right, so I'm going to do a quick recap of what we presented in midterm to give like a kickstart to this presentation. So, what is FarmBeats? FarmBeats is a Microsoft platform that really focuses on the the data aspect of farming, and it consists of sensors, drones, cameras, and the Azure cloud. And the general goal is to improve yields, lower costs, reduce the environmental impacts of farming, and just to help benefit farming overall. And then our goals for the semester. So we had really clear and defined goals. The first was to just create Power BI reports that displayed sensor data. Then to create a web application that made use of embedded reports that researchers and students could use to help in their research. And then to also document the entire process to help aid any future development on the project. So the deliverables for the semester was to have a working web API, to create Power BI reports, to create a web application with the embedded Power BI reports, and to develop and fully flesh out documentation on the project. So what we've accomplished. In Sprint 1, we got all of the accounts and really technical stuff taken care of. And we also had a lot of discussion with Microsoft and the Precision Ag team to get all of our requirements well defined and to help give us or to help clarify the goals for the project. For Sprint 2, we completed the web API with the research preview, and we went through a bunch of Power BI report designs. We got a lot of really good feedback in Sprint 2 from both Microsoft and the Precision Ag team, so we really were able to refine our Power BI reports. And as for Sprint 3, here we started shifting the web API from the research to the public preview, as the public preview was released right after midterm. So we had to make a lot of changes there. And we also integrated the API data with Power BI. So our Power BI reports were now using data that we got from our web API. In Sprint 4, we created the web application that has the Power BI reports embedded into it. We continued shifting the API over to the public preview. We finalized our specification documentation for our development. And one of the really nice things is we added drill through functionality to our Power BI reports. So you don't have to manually swap between tabs in the Power BI reports, and you could drill through directly to sections that you want. And as for what's left, we still have some finishing up to do with the public preview web API. It turned out to be a lot more work than we had originally anticipated. We still need to add functionality to a coordinate button. We originally wanted a little button you could press that would take your coordinates, and you would enter in a sensor name, and you could manually update the coordinates for a sensor. But we need to wait on that until the web API is completely finished. And we still need to create a short demo video for the NDSU website. And now for the web API, I'll turn it over to Henry to talk a little bit more about that.
All right, so for the web API, start off, there was two of them. We started off with the research preview, and then we moved on to the public preview. So for the research preview, this was back in the beginning of the semester. We had to start with learning about C# web APIs. I'd never worked with C# web APIs before, so I'd only worked with Java. So it took a few weeks to go through Visual Studio and learn how to do the web APIs in C#. And after some experimenting, we got all of that worked out. Originally, I thought the database was going to be a SQL database, so I created a fake SQL database, hit that, and then had it working in between the two. Then I learned that all of the data was stored on Azure storage accounts, so I had to learn how to do the new queries with Azure storage accounts instead of the SQL database. Also, since Azure storage accounts are being phased out and Cosmos DB is the new thing that they're trying to push for table storage. A lot of the new documentation was in Cosmos DB, so I thought that all of the data we would need to access through a Cosmos DB instead of an Azure storage account. And then it took a few weeks to get all of that working, so that way we were querying the right table instead of a new Cosmos DB table. Next slide, please. This is just some of the research preview data from the table. The public preview uses the same data as the research preview. It just hits the tables from their web API and then takes that data and imports it. I just wanted to show a background of what it would look like on the table side of things. Go to the next slide for me, please. This is what the output data looks like. It's just a bunch of JSON objects with ID, longitude, latitude, temperature, light, air temp, that kind of thing. The research preview was just those values you see up there, and it's slightly changed with the public preview, but it's basically the same thing, just a few added variables. Go to the next slide for me, please. Some of the services I had for the research preview was the two main important ones were the get all and the update location. So for Power BI, it is much easier for us to just take all of the data and import into it, and then sort it from the Power BI side of things, rather than to take individual sensors and import it to Power BI. But we also had a sensor and an individual farm method calls. The update location for the research preview, it by default doesn't include coordinate data. So we created a new table for sensor locations so that way we could query it and keep track of where the sensors are located. But with the public preview now, that is actually stored on the web API side of things. So you want to go to the next slide for me, please? So now I'm going to talk a bit about the public preview. So sometime around midterm, we switched it over to the public preview. The first few weeks we were spent trying to figure out how to query the FarmBeats web API, how it works, all of the documentation for that kind of thing. I then moved on to trying to query the database through Postman. I did direct HTTP requests, so I did all the get methods, all the post methods, trying to understand how to query the FarmBeats web API and then get that to work. And then after I tried to import that into the C# version of my web API, it didn't work because of the way access tokens work is you need to be able to log into a web page, and I couldn't do that directly from my web API. So we switched over to OpenID, which allows us to sign in and then get an access token so we can make all of our get and post requests. Next slide, please. So just on the bottom there, you can see examples of the FarmBeats web API. This is the Swagger documentation. On the left, you see all of the different possible method calls. And on the right, you see the example of telemetry, which is the post request that we need to make to get our data. You post to the telemetry with the sensor ID and then whatever the dates that you want to get, as well as the type of data you want. And then it'll return two objects. It'll return a list of all the times and a list of all the data. And so what we do for our web API is we just combine the times and the data into sensor, basically sensor lines, which includes the sensor ID and then the line of all of the data from that time period. If you want to go to the next slide. In our get all method, that's what our get all method does. And then our update location, the sensors now store on the FarmBeats web API the longitude and latitude. So the update location just takes an access token and then updates the longitude and latitude for the button. And that would be for our magic button that converts or adds a longitude and latitude to the sensor. Go to the next slide. So the authentication, like I talked about a bit about earlier, is I was doing OAuth 2.0. In the left, you can see what OAuth 2.0 is. It's basically you just have a client, and then you have a three-way handshake. So you first request the user to log in. Once they've logged in, you get a code back, and then you request the server for access, and then you get a token back, and then for that token, you can then get your data. And then after I couldn't get that to work with the C# requests, the mentors recommended OpenID, so we moved towards an OpenID system, which we're still working on right now. We got to the got through the login page and the access token is working, but some of the backend stuff isn't quite working yet. And so we're trying to get through that before we finish it all up. And after that, I will pass on to, I believe Jack is next with Power BI.
All right, so what is Power BI if you're not aware? It's analytics software by Microsoft and extremely useful for business data visualization or any data visualization, really. It's helpful to find trends. It just lays everything else out in like a nice, easy to read manner. And then the cool thing about it, which is why we're using it, is that it can be embedded into web pages and web apps very easily. The design we have is we have a main page that's a sensor map. And this will just have nodes for each sensor that kind of show up like a dot that you could click on. That's why we needed the coordinate information so that it would show up well on a map. And then from these dots, you can click on them, view each sensor's information, and drill through to other pages that we have. And our drill through reports, we have 3 of them: the gauge view, the line chart view, and the heat maps. All of these different reports can be filtered by time as well, and the time is consistent throughout each page. And we'll show this more during the demo. And then this is just kind of a mobile view. Since we can't demo a phone, this is kind of just a little short video showing how it looks like on a phone. Instead of it's basically just been optimized for vertical scrolling, as you can see from this video here. And then these layouts will automatically be used when a mobile device is detected. All right, I'm going to hand it over to Matt here.
All right, so now we have the embedded Power BI report. So we created a simple web page which contains the actual report itself. It is a single web page, as with drill throughs, there really isn't a need to have multiple web pages. And there's also a page to input, the latitude and longitude to update sensor's coordinates. I was originally looking into using geolocation. However, I saw that there was some issues with browser security where it wouldn't work. So I wanted to wait until we had this hosted to ensure that using geolocation would work for our magic button. And now I think it's the demo.
All right, so we're going to do a live demo. I'm going to hand this over to Matt. He's going to share his screen. This is a local copy that we have, but just so you know, we can take this local copy, upload it to Azure, and just host it there, and it'll work. So if the Precision Egg team wanted to do that at any time, they could. So I'm going to stop sharing my screen here, if I can. All right.
All right, is this visible to everyone?
It's visible for me, yeah.
Okay. So this is the general layout of our web page. So as you can see, the Power BI report is embedded in the web page, and it has all the functionality that the Power BI report that we demoed in the midterm does. So if you hover over a sensor, it'll show you a quick overview of information. So it'll show you its coordinates and the various other sensor details. And then as for drill throughs, if you right-click, there's an option for drill through. So you can go right to any of these pages. So if we wanted to go to the sensor charts, you'd click that. And then it would show you information for this sensor here. So you could swap between the different information. And if we go back, you just click the back button to go back, and then you could go into another sensor. So if you wanted to look at the gauges for this one, you just click that. And then, like Jack was talking about earlier, you can also sort it by time interval. So if we wanted to look just at 2019, you could click this and you'd see that it would update to that. Or if you wanted to look at month, you could look at November specifically. Our test data, we only have data for November and April. So there's those. And this time will also carry over to the various other parts of the report. So we are looking at November here on the for the sensor gauges. And if we went back and we drill through to the sensor chart, it would still show up as November. So that that time carries over across the different parts of the report. And we also have heat maps as well. Since there's only one sensor, we only have, or individual sensors, there's only so much like heat map data that we have. So that is what that looks like.
Yeah, and I'd just
then-
like to add here that the reason we're in Africa is because we just put in some random latitude and longitude test values, and it just happened to show up in Africa. So if we have actual sensor data from Fargo, it would show up in Fargo. It's just, so don't worry about that part.
I wanted to ask you really quick. I know, Matthew, we had trouble getting this simulator data in. How did you get the data, end up getting the data into FarmBeats for your accelerator to the show?
So the November data was old data that was in the research preview. And then I believe the April data was, we actually had a sensor set up in someone's apartment or dorm.
Yes.
And so we had like actual data to run off of there, but we really wanted to use the data simulator just to get extra volume or an extra like amount to actually simulate a farm instead of having just a few like sensors.
Yeah, that would be cool. This looks fantastic, though. It looks really, really good.
Thank you.
Thank you.
And then the last thing to cover for this is the coordinate section. So like we said, ideally, I'd like to use geolocation so that you could just enter the sensor name and click the button, and it would automatically update that sensor's like latitude and longitude based on the browser's current location. But we also need to wait for the API to be finished so I can hit the API and actually push the like latitude, longitude, and sensor name up to Azure itself. And then, unless I'm forgetting anything, I'll pass this back to Jack to display the rest of the PowerPoint.
All right. Why? All right. I'm gonna have to go back to my slide here. Hold on. There we go. All right, so the postmortem, I'm gonna hand it over to Zach to talk about kind of the wrap up.
All right, everyone can still hear me. So overall issues is that the FarmBeats didn't come out publicly until about the end of March. This caused our API development to kind of get held up. And then the data simulation was unsuccessful due to issues with Azure. Slide. Just some of our thoughts on the Microsoft tools and platforms we were able to use. Power BI was really helpful. Really no negatives there. Very great for visualization. As for Visual Studio, that was very compatible. Great templates. As of right now, though, we had a lot of package errors using Visual Studio. And then Azure, we had some account issues. And then a lot of confusing documentation that was in there. And then FarmBeats, it had a great web API. It was simple and easy. It was a little hard to work with the database scheme. And we can go next slide. Just some reflections. Even with the COVID-19 going on, I feel like we were all still able to call this capstone a success. The Power BI reports look great. And then our web API can be easily hosted on Azure at any time, like what Jack said. And then in the future development, I feel like any team could pick up where we left off, just using all the documentation we have. Slide.
Well, that's kind of the wrap up. And if you guys have any questions, we're all ears.